Alright, so good day, greetings. So this is a recorded video with regards to the hyperbolas. No? So I do hope that you're able to watch this recorded video once again for the hyperbolas. No? Alright, so as usual, let us start our day for a short opening prayer. Let us bow in our heads and feel the presence of our Lord. In the name of the Father, the Son, and the Holy Spirit. Amen. Lord, we offer you everything we do today. All our works, our joys, and our sorrows. Everything will be an act for love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Friend of the Lord, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, so for this video, we're going to discuss about hyperbolas. Alright, so our objectives for this day is none other than to write the standard equation of a hyperbola and to graph a hyperbola. Alright, so these are the objectives that we have for this recorded video. Alright, so with this hyperbola, I will be giving you a hint what hyperbola is and what hyperbola looks like. Alright, so in hyperbolas, what I could say, is there is a similar figure, or it has similarities between ellipse and parabolas. No? So if we say parabola, those are the graphs forming a U shape, correct? Alright, so in ellipse, these are the graphs, for conic sections that forms a closed shape, correct? Just like in circle, no? So what are the similarities between the hyperbolas to these two conic sections, no? So what I could say is that similarities between ellipse, no? What is the standard equation that we have for ellipse? The standard equation that we have is that x squared over a squared plus y squared over b squared is equal to 1, correct? So this is for the ellipse, wherein we could see that the major axis for the ellipse is at a or the major axis is at x-axis, or sometimes we could see that the standard equation is x squared over b squared plus y squared over a squared is equal to 1, correct? So this is the other standard equation that we could see in ellipse, correct? So this is where the major axis of the ellipse is at the y-axis, right? So if we're going to graph the ellipse using the major axis is at x-axis, or the axis of symmetry, this will be at this formation, right? So if it's in y-axis, it will be just like this, right? Correct. So in parabolas, um we have also a standard equation, correct? So when the axis of symmetry is at x or at y, right? So there is differences between them. Most likely, if the value of the center for the ellipse is at the center, or if the center of your ellipse is at the origin, and when the center of the ellipse is not in the origin, or it's in h and k, no? So same goes by with parabola. There are two things wherein you could find uh, the vertex of it when it's in origin, or when the vertex of it is not in the origin, no? So in parabola there is no center, right? So we use the vertex, correct? So therefore we could have the standard equation, most likely y squared, correct? Y squared is equal to 4c, okay, 4c x, right? So sometimes it could be x squared is equal to 4CY. So most likely we could see that if our axis of symmetry is at x x axis, the parabola shows or faces either left side or right side, right? Left side or right side. When the parabola, when the axis of symmetry of your parabola is at y-axis, the parabola is facing either upwards or downwards, correct? So it varies depending whether the 4C is positive or negative 4C, correct? So this varies depending on the sign of it. So therefore, you could have at least a positive sign and the negative sign of these two standard equation. No, so if it's positive, most likely in the quadrant, these are the positive ones, right? And these are the negative ones, correct? So same goes by in that cases. Now, so what are the similarities that hyperbolas shares with the ellipse and as well as the parabolas? Now, so let's start with the parabolas. So in parabola, we could see that the graph of a parabola forms a U shape, correct? So in hyperbola, they share same uh, graph. They share same graph with respect to equal parabolas, or they form two parabolas at the same time. No, whatever the value of this one forms with the other side, just it's just that with the other signs of it. No, so when you have up when you have a parabola facing upwards, you also have parabola facing downwards. So same goes by with the left side, and you have in the right side. No, so they are equidistant based on the center. Now, so therefore, we could say that hyperbolas also have a center. No, so even though hyperbola is not a closed shape, no, because we only know that the closed shape in conic section is the circle and ellipse, right? So the parabolas and hyperbolas are open shape, but we could say and we could really say that in order for us to graph up a hyperbola, no, we need a center once again, no. So therefore, in connect section, only this vertex, this parabola has the vertex as it serves like the center, no, because the other three connect section are having center spot. So therefore, they share same concept. It's like hyperbolas are just two equidistant parabolas, no. So that is the one po. This is for the figure, right? Figure. So how about for the ellipse? For the ellipse, hyperbola shares same similarity, or they share same concept in terms of equation, right? So if you say equation, how Sir Jai, if you're going to ask me, no, Sir Jai, how are you going to tell that they share the same equation? So if you're going to say that they share equation, so eh, therefore hyperbola is also an ellipse. No, so this is how, no. So in hyperbola, you could see at least the same figure. It has also equals to 1, no. The hyperbola also have a squared and b squared, as well as the x squared and y squared. So if you're going to input that one in this manner, no, x squared, a squared, y squared, b squared, right, is equal to 1, right? So this is what I'm saying. So the only thing that differs to them, no, or the difference between them for the hyperbola, no, to your ellipse, the difference between hyperbola to your ellipse is that when you saw an ellipse, the operation is positive. Okay, so while in hyperbola, what you could see is that the operation between these two fraction, no, is subtraction. So therefore, in order for you to know whether it is hyperbola or ellipse, is that hyperbola contains subtraction or an operation of subtraction, while in in ellipse it contains positive or so an operation of addition. All right. What else, Sergey? What is they share similar figures, okay? So they are in both fractional, they share like a and b, right? But the difference between them is that in ellipse we vary the major axis. Isn't it that we have major axis in your ellipse? We vary for the major ellipse. It varies depending where could we found the a, whether the a is located at your x or your a is located at your y, right? So in hyperbola, the difference between hyperbola to ellipse is that if your ellipse, the denominator of your ellipse is the one who's moving, so in hyperbola your numerator is the one switching, no? So your a squared and b squared are the fixed one that will not be switched, no, based on their axis or transfer axis. Later on we're going to discuss that one, no? So x axis, x squared and y squared are the ones going to be switched. So with this we are going to have at least two standard equation as well. So we have this first standard equation and the other standard equation, which is y squared over a squared minus x squared over b squared is equal to 1. Alright, so this is the other way how to this is the other standard form of the hyperbola, right? So this is the one point now, and no, and with this hyperbolas, we could also see that from the fixed variables that we have in the denominator, no, the sign also doesn't change even though we change the x and y, no, from their numerators. Even though we switch these x and y's, the operation didn't even change, no. So the operation is also fixed, it will not be moved. It's just that your x and y will be the one to be switched po. All right, only that one. Okay, so in hyperbola, what are the things we should remember? So if your ellipse in your parabola, no, let's write it down in this manner. You in conic section we have circle, ellipse, parabola, and hyperbola. All right. So these are the things that you should remember. In circle, the things that we need to find are the center, correct? Center, and the radius, right? So these are the two things that we need, we need to find, and for the center of your circle, it varies whether it's in the origin or at the values of h and k, right? Okay, h and k. So how about for the ellipse? Right, so in ellipse, of course, we also have a center, foci, and vertices, no? Vertices. So we could see that we are also needing center, foci, vertices. Let's just put it in initials now. So we have center, we have foci, we have vertices, we have co-vertices, right? Co-vertices, and the values of A and B, right? And as well as the value of your C, correct? So these are the ones that we need for the ellipse, right? So we get center, foci, vertices, and co-vertices, and as well as the variables that we have. So in parabola, the only things that we need is that from coming from the standard equation, we only need the vertex. Of course, vertex, we don't have vertices. We only have one vertex, no? Because it is the half. What we could say that the half of a an ellipse. That's what we view it, no? So we base on the vertex. So after vertex, we also need the focus. This is for foci, huh? Foci, then this is focus. Alright, so we have vertices, focus, and directrix, correct? Directrix, and as well as the latus rectum, right? And the value of C, correct? Alright, so there are times that the latus rectum are being asked, like what are the values, and what are the coordinates. All right. All right. So this is the C. Right? Okay. Okay. So these are the things that we need for the parabola: vertex, the directrix, the focus, and the latus rectum. Correct. And this for the circle. All right. So how about for the hyperbola? Okay. So for the hyperbola, as we said a while ago, we also need the center. All right, so we also have a center. So let's put center instead of C. Okay, center, and we also need vertices. Okay, this in this case we have two vertex, so we have vertices, or let's just put in letter V only. Okay, letter V, vertices, and we also have foci. All right, so we also have foci. What else, Jai? So we also have what we call as co-vertices. All right, so we also have co-vertices, and these are the co-vertices. These are the vertices. Okay, so we also share what we called as asymptotes. Okay, so we have the center, we have the vertex, we have the foci, we have the co-vertices, we have the asymptotes. Okay, so what are the asymptotes? These are the lines that you could see in a graph for the hyperbola, which these serves as the limits of the graphs. So it means our graph seems like they are reaching towards the limit, but they will not going to touch. No, they are not going to touch. Those are just limits, no, where the graph will not reach or uh, pass through that asymptotes. All right, so those are the asymptotes. Okay, so once again, center, vertices, foci, co-vertices, asymptotes. No, and also, we also have the values of A, B, and C. Right. So these are the things that you might wanna know with regards to the conic section. So let's just go back to the thing that I've mentioned with the similarities between the ellipse and the parabola. No? So in ellipse, as I mentioned, based on the equation, they are similar, no, in figures. So in finding the ellipse, we need the values of a, b, and c, correct? So in getting finding the values of a and b, it is really visible, no, based on the denominator, no. So how about for the hyperbola, Sir Jai? You said that they are similar, isn't it? They are similar, hyperbola. Okay. So the hyperbola also have a, b, right? How about for the c, Sir Jai? So in getting the value of c in ellipse, we have the formula of c squared is equal to a squared minus b squared, correct? While in hyperbola, we have c squared is equal to a squared plus b squared. So this are the things, no? So in the first place, I did mention that in ellipse, it is somewhat a Pythagorean theorem, but we will be changing the sign for the a and b, correct? So in a and b, why do we have this uh, subtraction? Because this only shows that in your ellipse you have a longer axis, which is the a, from coming from the center, right? You have the a and you have b, which is the shorter one. So therefore it states that in ellipse a are always larger than b, correct? While in parabola, a and b, I'll just put in ellipse, a are always greater to b, right? While in parabola, we could say that a could be greater or equal than b, or b could be greater or equal to a. Okay, could be that one, huh? That's the thing. So a could be greater or equal than b, or b could be greater or equal to a. So in this case, you could have at least these equal. They could be equal. The values of a and b could be equal, or a could be greater than, or is the greater one than a po. Now, so how are we going to find, or is it going to be a circle, just like what you've mentioned in ellipse, Sergey? Isn't it that you mentioned in ellipse, when you have the same value for a and b, if a is equal to b, that will form as circle, correct? Because they share the same radius or the distance, correct? While in hyperbola, even though they will be the same, no, it will not form as circle. Why? All right. So let's just try to go with a visualization with regards to our hyperbola. No, so um, hyperbola has focuses, also a center, correct, and as well as the vertices, right? So if this is your ellipse, this is the center, you have the two reference point, and these are your vertices. All right, so what happens in here, if this is the center, let's try to split this ellipse in two. Okay, so as you will notice, we formed two parabolas, correct? So this is your first parabola, this is your second parabola, right? So your first parabola is facing to the right because you have a reference point, so it means your graph will be facing at the direction where your reference point is facing. So therefore, if your focus, let's just say this is focus 1, if your focus 1 is in here, your graph will be facing right here, correct? Same goes by to the other side. So the reference point or the focus number 2 is here, then your graph will face towards the left side, correct? All right. So this, because this is your vertex, right? If this is your vertex, for example, this is your vertex, this is your focus, of course you're going to face towards here. If this is your vertex, this is your focus, you're going to face in here, correct? So just like that one now. All right, so let's try to visualize, like, what if the focuses, I will be erasing some lines now. What if the focuses, these are your focus, correct? What if your focuses transfer or moved beyond your vertex, no? Okay, this, if this is your center, this is your vertex, and this is your foci. I will be writing, this is your center, these are your vertex, and these are your foci. So what will happen in here? As I said, wherever your focus is and where is the vertex, starting from your vertex, you're going to go at your focus. So if this is your vertex, this is your vertex, you're going to your focus. If this is your vertex, you're going to your focus. Alright, so therefore you're facing here, you're facing in here. Alright, so therefore when the focuses overlap and passes through your vertex, no? So in this case, you might form a hyperbola. Okay, so in this case, your what else? Your co-vertices could follow like a big one. All right, so it could be equal with your vertices, or it could be in a short manner, no? So if you're going to have co-vertices, this is your co-vertices, no? These three, right? Let's just say let's just say you imagine we co-vertices could be larger or smaller, or it could be equal. If we are going to make a square, all right, so if we are going to make a square along the, let's just say this is the Cartesian plane, no? And the center is at the origin. We're going to graph it, and you have equal distance from the center up until to your vertex. If the measure of your A, or let's just say no, A is equal to your co-vertices, which is your B, okay, they could be equal, or they could be in a short manner, or co-vertices are shorter than your vertices, or sometimes your co-vertices could be larger or bigger than your vertices, no? So does it affect, Sir Jai, to your graph? Well, yes. Okay, no, it affects. How did it affect, Sir Jai? So here's the thing. Please always remember that coming from the center, no, to your vertex, this is this has the value of A. Alright, so in total, the the measure coming from your vertex 1 to your vertex 2, if you're going to measure it up, it will be 2A. Okay, so your for vertices, that is the value. All right, value of your vertices, or what's the measure, no? How about for your co-vertices? Of course, this is your B. If from the center to your co-vertices, the value of that one is B. Same goes y to the other side. So if this is your co-vertices 1 or co-vertices 2, if you're going to find the value or the measure of your co-vertices, it will be 2B. Alright? So what's the purpose of these co-vertices? Knowing that uh, we are not going to touch, we're not going to touch these co-vertices, right? So here's how. I'll be erasing this one first, no? Okay. Let's just have this one. Alright, so for example, this is still your graph. Okay. From your graph, with your co-vertices and vertices, if this is in a graph, we could somewhat form a broken line, right? It should be in broken line, huh? Because this serves as an imaginary limitation for our vertices. Okay. All right. Let's just say. Okay. All right. Right. Let's just say this is the broken lines. All right. So if you have like, let's just say that you have smaller co-vertices. Okay. So it means your square is in here, correct? In here, right? So this is the one, right? Correct. All right. So if that is your square, we could form a broken line coming from here up until to the other diagonal. We could form a diagonal line, broken diagonal line, and there, broken diagonal line, which serves as the limitations for your graph. So in in parabola, correct, we have what we call latus rectum. So with the help of latus rectum, we could know how wide your parabola is uh, opening, no? How wide is the opening of your parabola, no? But in hyperbola, knowing that you have already, though you could somewhat get by latus rectum, but it takes time. So these asymptotes also helps us, no, to identify how wide your graph would be. So if you have this shorter co-vertices and you have this vertices already, let's have this graph. For example, you have this vertices and co-vertices, and you have this asymptotes. So these are the asymptotes, okay? This broken line, the green line, right? So it serves as the limitation. So therefore, it only shows that your graph is opening this kind of line. All right. So that's I'm sorry, I should not did it. All right. So let's just say this one. Okay, this one. Yeah. Okay. So let's just write it in a manner like this now. So we could see that our graph is opening this kind of y. All right. They will meet, but they will not touch to each other. No, the graph is about to meet the asymptotes, but they're not going to meet. All right. So that's how wide our graph is. Okay. So what if your asymptotes, your asymptotes is not this one? So what are we going to do? Sige po. All right. So I'll be erasing this one first. Alright, so if you will notice, this depends on your A's, the values of A's and the values of your B's. Okay, so the important thing in here is that uh, the reason why we are getting the values of your A's and B's, that in order for us to get the values of our asymptotes. No, so this is how. All right. So if we use the second or the equal the covertices that has an equal value, this one has this square. If we use this square, let's just say they are equal. Let's just say what we could have in here is that we could form at least this. I'm sorry. This should be in broken line, huh? And this time we are going to make it in straight line so that you could see. Right. So this is how. Yeah. Let's just say this is how. Pardon with the drawing. So let's just say they are straight now. So this is the one. This is the one. This is the one. This is the one. This is the... All right. So let's just say that is your asymptotes, and the other one is this one. Okay. So these are the asymptotes. Imagine that they are a broken line. So in this case, you can have a graph, no? This kind of wide graph. Okay, that's how wide your graph would be. Alright. Okay. So that's how wide. Okay. Alright. So what if, Sir Jai, we use the third and wider graph? Okay. So let's just use this outer square that we have. Alright. Alright. So let's just try it already. No? Okay, so in that case, what you could have is to have this kind of asymptotes. Let's just say this is a straight line, alright? So this is the asymptotes that you have, alright? So in this case, it only shows that you have a graph, this kind of, what? I'm sorry. Okay, that's how wide your graph is, alright? Alright. Okay, so I hope so that you're now aware and familiar what asymptotes are and what are the covertices, no, shows for our graph, and why is it like they are equal, doesn't make like just like in circle, no? So this only helps us in order for us to find whether what are the asymptotes. And if you will notice, as I said a while ago, these are just like the ellipse, correct? So coming from the center to your vertices, the value of it is A. So therefore we have B, correct? So if you will notice the asymptotes, these are lines, correct? And we discussed about slopes. And if we say slope, it has the value of y is equal to mx plus b, correct? So let's just take this m, no? This is a linear equation, no? Let's just take the values of m, because we know that m is your slope, correct? So in this case, slope, your asymptote serves as a slope as well, no? It is a slope. So we also know that slope has the value of rise over run, correct? So therefore, if we rise, what is the value coming from the center when you rise? That has the value of b, okay? And when you run, you have the value of the vertical line, which is the value of a. So rise over run, okay? So this varies. So asymptotes has the values of rise over run, which your rise is b and your run is a. While there are times that a will be at your numerator and b will be at your denominator. So how is that so? So are you telling Sir Jai that your vertices are in here and your co-vertices are in here? Yes po. So in that case, your graph would be facing upwards or downwards po. All right, so that's how. So if that's the case, and this is the value of A, and this has the value of B, this is the value of B. If that's the case, so your rise would be A, and your run will be comes B. All right, so once again, this will be the value of A, and this will be the value of B. If that's the case, now if it's facing upwards or downwards. All right, so later on we're going to find out that one part. Okay. All right. So let's just wait with this one now. So let's have this. Okay, let's just erase this one. Okay, right. This one, this one. All right. Okay. So in this case, let's just go back to this one because this is the original form, isn't it? Because it is the co-vertices. And well, this is the vertices. So this is the value of A, and this is the value of B. Now, if we are going to to find what is the asymptotes, we have two asymptotes, which is the right one and the left one, correct? So this serves as positive and negative. Why did we say so? Because if we have the rise over run coming from your B over A, this B and your A, correct? As we progress, this is the B, this is the A. If you will notice, this slope is making, or the slope is about to rise. No? It is rising. No? While the other side, your rise, which is B, correct? You don't have you only you doesn't have you don't have B, which is always going up. Of course, you also have co-vertices below, so therefore you also have a rise, which is B, correct? So therefore you have B going down and A, which is going to the right, correct? A and B once again is going down, and A going to the right. Or in other cases, we could say that you have B, let's just say you have B and A, and you have B and you have A. In this case, what we could see that this is going to the left side, and we don't want that one, isn't it? That in Cartesian plane we always read from the left side going to the right side. So the proper way in reading slopes, in lines, it's always left going to the right. So therefore this is the correct one, huh? All right, so we could say that this slope b over a is going downwards, correct? So therefore, this is negative. And your slope, which is going this one or upwards, it is positive. So you have positive and negative b over a, or positive and negative slopes. Okay? All right. So let's just say this one. Let's just have this one already. So what if you have a center? And let's just say this is the graph. Okay. So you have value of A and B. You're going to find the value of A's and B, correct? And you also need to find the center, the vertices, the foci, the core vertices, and the asymptotes. Alright. Okay. So, in order for us to find the values of center, of course, that is the center. It could be in the origin, or it could be at the values of H and K, correct? Alright, so if in your equation you found H and K, of course, you have the values of center, which is not located at the origin. No? So for the vertex, as we know, it has the values of A, right? And for your co-vertices, it has the values of B. Okay, so it has the values of B. How about for your focus? So your focus, it has a value of C. Okay, I'm sorry. So this is the center. Okay, so this is the center. If you have the vertices here, you have the focus here. Let's just say this is your co-vertices. Okay, so the value coming from the center up until to your vertices, uh, it has the value of B. It has the value of A rather. It has the value of A. In total, you have 2A, correct? From coming from the center to the co-vertices, you have B, correct? But if you have the measures coming from both ends of the co-vertices, you have 2B, okay? 2B, alright? While coming from the center up until to the focus, no, you have the value of C. Or if you will get the measures, both ends coming from the first focus to the other focus that you have, it will be, of course, it's 2C. Okay, 2C. 2C. Right? So in this case, we are going to find the values of A, B, and C. No, this A and B will be based on the equation. Whatever your equation, you're going to get the values of A and B from the equation, right? So it will be fixed. This is for the equation. And this C will comes from the equation of C squared is equal to A squared plus B squared, correct? Okay. So in this case, these are the values for A and B, and we know that uh, it has 2 points in each values for A and B, correct? So it seems like in ellipse as well, you have vertices, so therefore you have two vertex. So it means you have two coordinates, no? So it will be positive and negative. Okay, positive and negative A, because you have two vertex, first one and the second one, correct? The same goes by for your focus, which is the positive and negative focus, which is the first one and the second one, correct? And also for your B, which is positive and negative. So this is your first one and your second one, or either way. No, so this only shows that you have two coordinates for vertex, you have two coordinates for focus point. No, so it will vary depending on what is your axis of symmetry. So how are we going to find what is the axis of symmetry in hyperbola? That is the question. Okay, so as we remember, in order for us to get the major axis in ellipse, we are to found wherever the A is located, whether it's in X or in Y, that will be your major axis. While I will be writing, if this is the ellipse, if this is our ellipse, if your A is at your x-axis, so therefore your major axis or axis of symmetry is x-intercept, correct? While when we saw that your equation, let's just say your equation, you could see that a squared is along with the x, therefore the axis of symmetry is just x. But when they interchange, okay, when they interchange, for example, y squared over a squared minus x squared over b squared is equal to 1, you could see that your a, okay, your a is along with your y-axis. Okay, so therefore the axis of symmetry in here is that y. Okay, so therefore your vertex, which is a, correct, your vertex is your a, so therefore your vertex will be based on your center, correct, because in your center you have h and k, and we know that your h is your x-intercept and k is your y-intercept, correct? So in this case, we know that a is at your y-intercept. So therefore, you are going to add and subtract the value of a to your k, because k is your y-intercept. So therefore, the coordinates of v or vertices is h, comma, positive and negative a. Okay. Oh, that's how, or that is the coordinates, the two coordinates of vertices. Now, how about for focus? Oh, we know that in ellipse, vertices and focus or foci lies on the same axis. Okay, so they are just neighborhoods, no? So we could say that also in hyperbola that vertices and focus or foci are just lying at the same axis. So wherever the vertices lies, there will be, that would be the same intercept where where the focus or foci should lie also. So if your vertices lies at y-intercept, so therefore you're going to add and subtract as well at your y-intercept. No? So you're going to add and subtract c at your y-intercept as well. How about for the b? We know that in ellipse, when you have the major axis, of course, you also have the minor axis, which is perpendicular to it, correct? So therefore, if you say perpendicular, whether your vertices is at x-axis, so if we say perpendicular, no, it performs 90 degrees. So therefore, it is the opposite axis that we could get, no, in the graph. So if your axis of symmetry is y-axis, so therefore the perpendicular axis of y-intercept is x-intercept. So therefore you're going to add, please wait, I'll just I'll just correct this one. This is correct. I'll just add up. uh, Coming from the vertex, coming from the vertex, which is h and k, correct? For your vertices, you're just going to add and subtract values of a. And for your focus, you're just going to add and subtract c. And for your co-vertices, coming from your h, because it is perpendicular, correct? We're going to add and subtract b, then k. Alright? So that's how. And for your asymptotes, okay? For your asymptotes, knowing that co-vertices is b and it is in your x-axis. Mhm, mhm. I'll just correct this one. If this is, let's just say, let's just erase this one, this one, this one, this one. Okay, let's just say this one. I'll just fix this one. Coming from the equation, assuming that you have this equation, your vertices is at y-axis. So therefore, coming from the center, therefore your vertices lies at y-axis. So if this is your if this is your vertices, this is the correction, correction. If this is your vertices, you have the focus, of course, the C. Okay, so therefore, this is your A already. This is your A, and coming from the center up until to your focus, that is your C. correct? That is your C. Alright. So therefore your vertices is at x-axis, and it is noticeable, no? Because it lies at x-axis. Okay, so that has the value of b. Okay, in order for us to get the asymptotes from the formula of your slope, okay, or let's just say the value of m, it is rise over run, correct? And our rise in here is that the rise is a, so therefore a and your run is b. Alright, so you have positive and negative b, or we could say that your slope is positive, negative I'm sorry, a over b x. Okay, x. Alright, so don't forget that one. Why do we have x? Because if you will remember, the linear equation is y is equal to mx. What is the mx? See, so we could see that we also have the x-intercept. All right, so with this things in hyperbola, I know you could graph it already, no? But before that, let's have this hyperbolas for the given already, no? For the given, we have x squared over 9 minus y squared over 4 is equal to 1. So in this case, our standard equation, which x is the first place, correct? So we could have x squared over a squared minus y squared over b squared is equal to 1. So our axis of symmetry in here, mm, axis of symmetry in here is, what is our axis of symmetry? Our axis of symmetry is x-intercept. Okay, x-intercept. How about this one? The axis of symmetry of the other one is that from the standard equation, y squared over a squared minus x squared over b squared is equal to 1. What is the axis of symmetry, or the transverse axis of symmetry? Our axis of symmetry is y. Okay, this is y. Okay, so our axis of symmetry is y intercept. All right, so let's just go back to the graphs that we have. So let's just clean up coming from the center up until to the coordinates. Okay, so if this is your graph, let's just say this is the graph. No, we have what we call the conjugate axis and transverse axis. So in ellipse, we have major axis and we have minor axis. So in hyperbola, we have what we call as transverse axis. So in transverse axis, this is the axis which we could found on the vertices. So coming from this point, okay, into this point, this is the transverse axis, and our conjugate axis is the one with the co-vertices. All right, so this transverse, okay, verse axis, and we have the conjugate, okay, conjugate. All right, so let's just go back in here. So these are the axes of symmetry, no? But I will be asking you. So this is in. These are the examples which we could easily found because they are in standard form, correct? Standard form. All right. So how are you going to identify if your equation is not in standard form? What if your equation is at general form? Okay. So last time uh, we were able to know how to convert from the general form to the standard form. So by this day, we're going to find out what are we going to do in order for us to make the standard form to general form. Okay, so coming from your standard form, the rule here is that there should be no, there shouldn't be any denominator at your equation. No, so in this case, we have denominators, and what are those denominators? We have 9 and 4. How are we going to eliminate this denominator? So in the case of this example, we're going to get the LCD. What is the LCD? In the best and the quickest way, in order for us to get the LCD, let's just multiply it. Okay. What is the product of 9 and 4? The product of that one is 36. Correct. 36. Okay. So this is the LCD. Let's copy the operation, which is minus. Alright, so we have the first numerator and the second numerator. So how are we going to find the first numerator? Coming from your LCD, we're going to divide. 36 divided by 9, what's the answer? It is 4, correct? So from the quotient that you have, you're going to multiply this one to your numerator, right? So you have x squared, right? So 4 times x squared, the answer is 4x squared, correct? So you have your first numerator already, okay? How about for the other side? So in this case, you have 36 as your LCD. So once again, same process, you're going to divide 36 divided by 4. What is the answer? It is 9, correct? So 9 multiplied by y squared, the answer is 9y squared, correct? Then you just equals to 1. Now, this the case. So I'm sorry, this is the case. We have 36 below. Okay, so in this case, we were able to get the LCD of the two fractions, correct? So is that so? Did we eliminate the denominator? Of course not. So how are we going to get the how are we going to eliminate the denominator of this equation? So in this case, we're going to multiply both sides, no, both sides coming from your left side and to your right side by 36. All right. So if we multiply both sides in 36, it could fall as 36 multiplied by 4x squared minus 9y squared, correct, all over 36 is equal to 36, right? In this case, we could cancel 36, right? So in this case, we could have 4x squared minus 9y squared is equal to 36. I'm sorry, it's 36, okay? 36. So in this case, do you think that this is the final answer? Is this the final answer? Alright, so this is our final answer. Okay? Alright, so let's try the uh, other, the second standard form. No, so from coming from the y squared, no, how are we going to eliminate this two denominators? So first is we're going to get the LCD by multiplying the two denominators. So 25 multiplied by 16, that is 400. Okay, you could just check on your calculator. So after you get the LCD, copy the operation, which is subtraction, then find the first numerator and your second denominator. In order for you to find the first numerator, you will divide your denominator or your LCD to your first denominator, which is 25. So 400 divided by 25, what would be the answer? So you could have 16, correct? Right? So 16 multiplied by y, what's the answer? It is 16y squared, right? And how about for the other numerator? 400 divided by 16, that is 25, correct? And when we multiply 25 multiplied by x squared, the answer is 25x squared, correct? Alright, so let's just erase something. Let's just fix something so that it will not be kind of confusing. Alright, so we have 16y squared minus 25x squared over 400 is equal to 1. How are you going to eliminate this denominator? No? So in order for us to eliminate this denominator, we're going to multiply both sides by the value of your denominator, which is 400. Alright, so once we multiply it, we could cancel this out already, right? And you could have the answer of 16y squared minus 25x squared is equal to 400. Okay, is that the final answer? Yes, and that would be our final answer. And I do hope that you already know how are we going to eliminate, no, these uh, denominators. All right, so just that's how simple it is. All right, so in simplest thing, how are you going to find the general equation of this one is that let's just try to multiply both sides by the LCD of it. No, this one. What's the LCD of this one? It's 36. So when you multiply that one by 36, you could automatically have 4 in here and 9 in here. And you could have the answer once again. Okay? Alright. Okay, so this is the other slide. This is the one that I am mentioning a while ago. So what would happen if we pull the two foci, no, or the two focus of an ellipse, no, so far apart that they move outside of the ellipse. So once again, this is the ellipse, this is the center, this is the focus, no, the foci. So once we move them outside of the ellipse or beyond the vertex, they will result as a hyperbola, no? Or another conic section. All right. So once again, a hyperbola, no, is a set of points wherein points are the x-intercept and y-intercept in a plane, such that difference of the distance from the point to the fixed point focus 1 and focus 2 is uh is constant, no, and this focus 1 and focus 2 are the foci. All right, so if in parabola we have this what we call as the directrix, no, in hyperbola we have what we call as uh the transverse axis, no, and the directrix that you might wanna imagine is the conjugate axis, but in this case we only have this constant point which is the foci. Okay, all right po, sige. So for a hyperbola, d is equal to the magnitude of point multiplied by point focus 1 minus the product of point in focus 2 po. No, where d is the constant difference. Okay, so you can use the distance formula. And you know what is the distance formula, right? And I just want to show you some slides with regards to what are the things that we could see in hyperbolas, no? This is the one. So we have the standard form of the equation of a hyperbola depending whether it's in horizontal and vertical, no? Depending what's the transfer axis, no? In ellipse we have what we call as the major axis. It depends what is the major axis or the principal axis, what we call, no? The principal axis. So in hyperbolas, what we depends on is the transverse axis. Okay, so a when the a is within the x, so we could say the vertices lies at x axis. So therefore your graph is at horizontal. And when your A is with y-axis, so therefore your vertices lies at y-axis, right? So therefore your graph is vertical. Okay. Okay. So the values A and B and C, this is the one that I'm saying, no? So we use this equation in order for us to find the value of C. Okay, so this 2A from coming from the two vertices that I've mentioned a while ago is what we call as transverse axis. And the length of the 2B, that is what we call as conjugate axis. Okay? Alright. So I have here a table which the values of a, b, and c are related by the equation c squared is equal to a squared plus b squared. No, and if you will notice, this is the one that we made a while ago. So when your a is at x-axis, you will add and subtract at your x-intercept. Okay. So same goes by for your focus because they are just neighborhoods. Okay, but as we said that co-vertices are perpendicularly seen based on the axis, no? They are perpendicularly seen to the vertices. So therefore, if your vertices are at the x-axis, so therefore the co-vertices at is could be found at your y-intercept. Okay, so we are going to add and subtract b. All right, and as I mentioned a while ago, if your vertices is located at x-axis, so therefore, is it is your run, correct? And when your co-vertices is at your y-axis, so therefore it will be your rise. Okay, so therefore you could have the value of y is equal to positive and negative b over a x. Okay, that will be your asymptotes when the graph is at the horizontal. So vice versa for your vertical. No, if you will notice, it's in the y-intercept already. The vertices in the foci where your co-vertices is at the x-intercept. So therefore, you just change as well the asymptotes. All right. So this is where we could found where the center of your equation is at this at the origin. Okay, so in this case it will just vary, no, depending to the center as well, if your center has the value of h and k, the one that I'm saying. So for the other slide around, I also have this hyperbola terms that you could use in order for you to be familiarized with. So this is when the center of your hyperbola is not in the origin, so you have the values of h and k. Now, so the equation form for this butterfly, because it's in horizontal, if you will notice, they are facing left side and right side, correct? So they are horizontal. Okay, so the equation form in here is that x minus h squared all over a squared minus y minus k squared all over b squared is equal to 1. So if you will notice, your a squared is within x-intercept. So therefore, your vertices lies at x-intercept. Okay, so the axis or the transfer axis is parallel to your x-axis. Okay, so that's how. How about for your center? The center, of course, that is your center, and it has the values of h and k. Okay, so these are your vertices. Alright, and this is your vertices, the other vertices. So you're going to add and subtract. That's the one that I'm telling a while ago, because you have two coordinates. No, whether you add and subtract based on your center. Okay, if your vertices is at x-intercept, so therefore you're going to add and subtract at your x-intercept, which is h. No? So in here you will see that the values of a was added and subtracted to your h. Okay, so same goes by for your co-vertices. It is perpendicularly found, no, in the axis, which you will be adding and subtracting the values of p. So this is what we call as your A's and B's. Okay, so this is your focus. Okay, focus. And as we mentioned a while ago, coming from your 2A, that is what we have, or that's what we have now as transverse axis. And your transverse axis is horizontal. Okay, and the length of your transverse axis, again, length or the value of your transverse axis is 2A. Okay, and for your conjugate axis, of course, that is perpendicularly to your transverse axis, which could be found at your co-vertices. Alright, so your conjugate axis is vertical. And we could say, and we could found that you can perform and you could see an asymptotes, correct? Asymptotes based on the graph that you could found for your co-vertices, right? Mm. What are your co-vertices? These are your co-vertices. These are your vertices, right? That's how these are your asymptotes. And you will see that is our square that I'm telling a while ago. No? And the length of your conjugate is 2b. Alright? 2b. Okay, so how about your foci? So your foci is available, no? You will be able to get your foci based on c squared is equal to a squared plus b squared, and that is your focus. No, same goes by for the other side. No, all right. Okay, so that is your focus. So you're going to add and subtract as well wherever your vertices added. No, so next intercept always because they are just neighborhoods. All right. So the other table hyperbola terms is that when the transverse axis is at y-axis. No, so if you will notice, y minus k squared, your a squared is located at your y-intercept. So therefore, you have y-intercept, or the axis of symmetry is at y-intercept, and you have the center, which is h and k. Correct? All right. That is your center. No? And these are your vertices. Right? So you're going to add and subtract at your y-axis because your intercept is at y-axis. No? So you're going to add and subtract the values of a, no, to your y-intercept. Okay, and just to notice, this is your co-vertices, and therefore you're going to add and subtract at the opposite intercept of your vertices. So therefore the opposites intercept of y-intercept is x-intercept. So you're going to add and subtract the value of b at your x-intercept. Okay, so this is our transverse axis. No, so transverse axis could be found where your vertices and foci lies with. Okay, so the length of your transverse axis is 2a and it's in vertical, correct? And this is your conjugate axis, and your conjugate axis, if you'll notice, it's in horizontal manner, and the length of that conjugate axis is 2b. Okay, and this is your foci, the length of your foci. The value of that one is c. No, and obviously, how are you going to get the value of c? In order for us to get the value of c is c squared is equal to a squared plus b squared. So we are going to add and subtract at the y-intercept. No, same goes by for your vertices. Alright, so you're going to add and subtract c to your y-intercept. So with that, we could also found our asymptotes. And the formula for asymptotes is this one. No? Your run is A. This is your A, and your B is, this one is your B. Rise over run, so this is the one. So in hyperbola, no, when the center of your hyperbola has the value of h and k, from the original form that from the original equation that we have last time, no, we have what we have: y is equal to let's just say this is b over a correct? This one, y is equal to positive and negative b over a x, correct? So this is the formula when, or this is the equation when, no, when when the center of your hyperbola is at the origin, but when you have the value of h and k, so therefore you just add. We mentioned this one already, that when you have x, the partner of your x is minus h. Okay, once again, minus is an operation and h has different signs or values. Okay, so therefore the same goes by to our other side, which is this one, correct? Mm. Our asymptotes is this one. Okay. All right, so let's deal with some examples. So our example is we're going to find the vertices and co-vertices and the asymptotes. No, so we only need to find three things. So the vertices, which is A, and the co-vertices, which is B, and the asymptotes. All right, so with this, the step one is we could see that 49 is A squared, right? So a squared is equal to 49 because from the standard equation, what is your standard equation? Your standard equation is x squared over a squared minus y squared over b squared is equal to 1, correct? Alright, so if you'll notice, your a squared is 49 and the one that you will only needing is a, so we're going to square your 49 in order for you to get the value of a, correct? Mm. So the square root of 49 is 7. So a is equal to 7, positive and negative 7. Why did we say it's positive and negative? Because you have two vertex. So you have vertices, no? So either you add and subtract. Alright, so therefore you have a is equal to positive and negative 7. Correct? Same goes by with this one because this is your b square, correct? So therefore your b is equal to positive and negative 3. Okay, so this is the question: how are we going to uh, add and subtract, or where are we going to add and subtract the values of your a's and b's? So of course a will be added at your a squared, x-intercept. uh, there's positive and negative 7 is added at the x-intercept, while your 9, or the value of your b is 3, no? It was added and subtracted to your y-intercept. Okay, all right, so we are done at vertices and co-vertices. How about for the asymptote? So step 2 is we're going to draw a box using the vertices and co-vertices, no? In order for us to draw the asymptotes, no? So we're going to draw the hyperbola already using the vertices of this one, no? So coming from the center, what's the center? It's 0, 0. Can we see any values of h and k? You cannot see anything. So therefore your center is at origin. So therefore your vertices is positive and negative 7. So therefore this is your vertices, and your co-vertices is here. Okay, so we are going to draw a box on it. That is the step 2, right? Broken box, broken box. It should be broken box here. Okay, so in that case now we could already see the asymptotes. This is a vertical uh this is a broken line, just imagine broken line of all of that. So therefore we could see your graph is facing left side and right side, left side and right side. Okay, all right, so next we're going to write the equation of the hyperbola. So we're going to write the equation of the hyperbola wherein your center is at the origin and you have the vertex of 4 and the focus, which is 10. So our vertex is A. right? And our focus is C, right? Okay, so step one, we know that when the center is at the origin, of course it's 0 0, and therefore you couldn't find any values of h and k, right? So how are we going to uh, how are we going to know whether the axis of symmetry is at the x-intercept or y-intercept? In order for us to find whether it's x-intercept based on your vertices and focus. If your vertices and focus lies on your x-intercept, x-intercept, so therefore x comes first at the equation. Alright, so it will be x squared over a squared minus y squared over b squared is equal to 1. Right, that will be your uh, equation. But you have the values of a, right? A is equal to 4, but you need square. So therefore, you're just going to square it. 4 squared. What is the square of 4? It is 16. Alright, so you have the values of 16 already. How about for the b? How are we going to find the value of b? Alright, so this is how. Step 1, what we did is correct. And for your step 2, from the formula, okay, from the formula, which is c squared is equal to a squared plus b squared, correct? So in this case, we are to find the value of b squared, and the value of your a squared is 16. What is 16? What is your a squared? It is 16. And what's the value of your c? That is 10, but you need to square it. So 10 squared is 100. So in this case, no, we're going to add something to 16 in order for you to find 100. In that case, okay, b squared, you're just going to transpose it to the other side. So 100 minus 16 is equal to b squared. And 100 minus 16 is 84. So therefore, your b squared is equal to 84. Alright, so therefore, we have the equation already. Okay, that's how. Okay, so I just want to uh, give you this already. So we're going to graph and label this equation, this hyperbola already. So we're going to find the coordinates of vertices, co-vertices, and foci coming from this equation. No, you have the values of h and k. So therefore, this center is -5 and -2 for your x-intercept and y-intercept. Okay, so it is x minus h, correct, and y minus k. All right, this is operation, and if you have the negative value of h and k, therefore it will be positive. Anyways, so in this case, you could see that your a squared is at x-intercept. So therefore, your vertices lies at x-intercept. Okay, so therefore, either way, it is facing right or left. So therefore, it has the shape of butterfly shape, right? Okay, so since we have the 4 as your denominator for your x and 9 for your y, that is for a squared and b squared, but we are going to find the value of a and b. Therefore, we have the value of a and b as 2 and 3, right? Okay, so in this case, we're going to find the value of the coordinates of the vertices. How are you going to find that one? You are going to add and subtract the value of your a to the x-intercept because a squared is with the x, right? So therefore, you could have the center coming from your center. It's -5 and -2, -5 and -2. So you are going to add the value. You're going to add and subtract the value of a to your x-intercept, no, because it's in x-intercept. All right, so For your co-vertices, of course, you're going to add and subtract. No? You're going to add and subtract. That's one. You're going to add and subtract the value of your co-vertices, which is b. Add and subtract in y-intercept because your b squared is at y. So therefore, coming from your center, -5 and -2, you're going to add and subtract at your y-intercept, the value of 3, no? The value of p. Alright, so in that case, we're going to find the value of focus. Okay, so using the formula c squared is equal to a squared plus b squared. So in substituting all the terms, it will be, no? 9 plus 4, it equals to 13. And therefore, we found the value of c, which is positive and negative square root of 13. And we are going to add, in order for us to find the coordinates of uh, focus, is that, or foci, is that we are going to add and subtract that one to the x-intercept of our center. Okay, oh, that's how. Okay, so this is how are we going to graph that one? We're going to plot the center. Okay, this is our center, and we're going to go two on 2 units, going to the left and going to the right, and this is our vertices, and we're going to have our co-vertices, which is 3 units going up and going down. Okay, and we're going to make a square, no? And what that square is, the purpose of that square, that would be our asymptotes. Okay, and with that, we could see that we formed the graph for your hyperbola. Okay, so next, first is we're going to find the coordinates of vertices and co-vertices. Now, so we have the values of h and k. So our h is 1, and we have the values of k, which is uh, 3. No, so our center in here is that -1 and +3. Correct. So that's our center. So since you can see that our a is at y-intercept, so therefore your vertices lies vertically. Correct, vertically. So therefore your vertices or your graph could be facing upwards or downwards, right? So it could be shaped at hourglass, okay, in white terms. Now, and if you will notice, white y is the first term po, okay? So in this case, we know that the first denominator is a squared and your second denominator is b squared. So therefore, we're going to find the value of a squared, the value of your vertices, which is a. So we have a squared, which is 4. A squared is equal to 4. In order for us to find the value of a, we're going to square both sides in order for us to get the value of a, which is the square root of 4 is 2. Therefore, you have the value of a, which is 2. And same goes by the process for your b. So you have the value of a is equal to 2 and b is equal to 4. Alright, so therefore, you're going to add and subtract 2. Okay, you're going to add and subtract 2 units, no, to your y-intercept because you are the a squared is with your y. Okay, all right. So therefore, you're going to add and subtract based on your center, which is -1 and 3. -1 and 3. You're going to add and subtract to the y-intercept. Okay, y-intercept. All right. So same process. So for your co-vertices, it is perpendicularly. So therefore, you're going to add and subtract to the x-intercept. Okay, so you're going to find the focus for this terms. So therefore, what is the value of what is the formula or what is the equation? It's c squared is equal to a squared plus b squared, and we have the values of a squared and b squared, which is 4 and 16. Correct? Okay, so therefore, we're going to substitute the values of a squared and b squared, which is 4 and 16, correct? So in that case, we could see that the values of 4 and 16 is 20. Then therefore, we could have the value of c, which is square root of 20 or positive and negative 2 square root of 5. So you could just find the lowest term, or just simply write it as square root of 20. Alright? So therefore, our focus, you're going to add and subtract that one wherever you add and subtract to your vertices. So in this case, you add and subtract to your y-intercept. So therefore, same goes by with your focus or your foci. You're just going to add and subtract to your y-intercept. Okay, so let's now graph. So if we're going to graph, we're going to plot the center first, which is -1 and 3. So this is your center, and we are going to go up and go down 2 units from this center. Okay, because that is your vertices, correct? You have the values of vertices and co-vertices, which is 4. So you're going 4 units going to the left and going to the right from your center. Once again, from your center. Okay, so if you'll notice, 1, 2, 3, 4, 1, 2. Okay, same goes by to the other sides. Alright. So in that case, after you plot all the vertices and co-vertices, make a shape on it. Okay, so whatever the points from here to here, you just connect that one and continue that one outside. Alright, that's how you could find the asymptotes. Okay, and with that, you could now have how wide would be your graph is. Okay, alright. So with this example, let's have this one. We're going to find the vertices and co-vertices and asymptotes of this hyperbola. Alright, so step 1, we have the value of a squared and b squared, correct? So a squared is 16, so therefore your a is 4 and your b is 6. Getting the square root of both sides, getting the square root, correct? Alright, so coming from your equation, you could see that your a squared is at x-axis. So therefore, your transverse axis is horizontal. Why? Because your intercept or axis of symmetry is x-intercept or x-axis. Okay, so in that case, we could see that we could say that your graph is horizontal, right? Or in butterfly mode. And let's have this one already. So you could have the values of 4 and 6 as your A's and B's, correct? So you're going to add and subtract for your values A and B. Therefore, you're going to add and subtract to the values of X, correct? You're going to add and subtract for your B to the values of Y-intercept or to the placements of Y-intercept. Alright, so that's how. And for your step 3, you could have the equation for your asymptotes already. Okay? Alright, so how? So this is how. So you have the vertices. What is your vertices? Vertices are coming from your center. You don't have any H and K, right? So this is your vertices. This is your center, and these are your vertices. Vertices. Co-vertices. Okay. So we are going to have a shape or that is broken line. Don't forget this broken line. That is your broken line. Alright, that should be broken line. So we could have the asymptotes of this one. This is broken line as well. This broken line. I'm just doing like this. That should be broken line. Alright, so therefore you have the value of b, which is up. Here you have the value of a, which is right. Therefore your run, rise over run, I'm sorry. Alright, so therefore your rise over run is b over a, correct? So therefore we could say that run or your rise is 3 and this one, this one, we could have the value of b, which is, what is your rise? That is 6. Okay, and you have the value of a, which is 4. Okay, it is positive and negative 4. Okay, alright, sige. Okay, so if you're going to find this one already, okay, so let's check this out already. So we are going to write an equation in standard form. Standard form for each hyperbola. So we have the vertex and co-vertices. So step 1, we know that a squared is for vertex, and this is the value of a is 9. Alright, so we have the positive and negative 9. So therefore, if we're going to find the a squared, you're just going to square that one. So therefore, your a squared is equal to 81, right? Your co-vertices is 7. I'm sorry, 7. So therefore, if you're going to square that one, you just square it at 7. So therefore, your b squared is equal to 49. So therefore, you have 81 and 49. The question is, how are you going to find what is the placement of your a squared or b squared? Of course, you have a squared and b squared, just like that. No? But the question is, how about for your x and y squareds, right? Hmm. We know that we could see that your vertex is at y-intercept, so therefore y is at here. And you see that your co-vertices is at your x-intercept, so therefore b squared is with your x. Alright, so that's the one. Okay, right? Okay, so that is your step 1 and step 2. Right? So therefore we could write the equation already. Right? So therefore your equation would be 81 as your denominator for your y and 49 as your denominator for your x. So therefore you have y squared over 81 minus x squared over 49 is equal to 1. Okay? Alright. So this is the other one. So we're going to write the equation in standard form for each hyperbola. So same goes by. This is your a, this is your c. So you're going to square both a and c so that you have the values of your a's for your formula is equal to 64. C squared is equal to 100. Let's just find out what is the value of b squared. C squared is equal to a squared plus b squared. C squared, the value of your c squared is 100. So you're just going to write it 100 is equal to 64. So what numbers do you what is the number do you think that we could add to 64 in order for you to have 100? So in other case, you could just simply transpose the 64 to the other side, so it will become 100 minus 64 positive to negative, correct? So it's equal to b squared. So 100 minus 64, the answer is, well, what is the answer? It's 36. Okay, 36 is equal to b squared. So this is your b squared. So therefore, if our equation is a squared is 64 minus your b squared is 36 is equal to 1, and you know that your vertex is at x-intercept, same goes by for your focus, so therefore x squared comes here and y squared for your cold vertices. Alright, so I'll just erase this one and I'll just see you the final answer. So this is for our final answer. Okay. Alright, so with that, I hope that you learned something about the hyperbola, and I do hope that uh, you really learned a lot with this recorded video. And thank you for your time watching this video in hyperbola. Alright, so once again, thank you, grade 10, and see you on the next video. Bye.